Hello, good morning everyone, and welcome back to White Fortress Cybersecurity. I hope I'm audible to you guys. So, in the last class, we talked about ARP, that is your Address Resolution Protocol, and we revised IP addressing and classes of IP, types of IP, and everything, right? And if you guys have any doubts, you can just ask me. Also, for the doubts, you can contact on the number that is in the description. So we also talked about what is DHCP, what is APIPA, and how does it work. Then we also talked about MAC addressing, which is also called your physical address, and whereas your IP address is called your logical address. So we also discussed MAC spoofing and man-in-the-middle attack. Then we talked about packets, that data is transmitted in the packets, right? Next, we have got the data transmission, electrical signals, optical signals, wireless signals. We discussed it all. Then modes of communication, simplex. We also call that simple duplex or simplex. Then we have half duplex. Then we had full duplex. We discussed it all. Then types of communication, multicasting, unicasting, broadcasting. And today we are going to cover several topics that are very important to understand this networking theory part. Then we will get to the practical part using Cisco Packet Tracer. I do not have any problem if you want me to give classes in Hindi or English, any language will work. And also do not forget to like the video and subscribe to the channel. Let's begin. So, first topic is ping. What do you understand by ping? Ping is simply like, for example, I say ping me whenever you are free. That means contact me, check if I'm available or not, so that we can communicate later, right? So you ping me or I ping you just to check if you're available at the moment or not, if you are reachable or not, right? So in the systems also, ping is used for this similar thing. So ping uses ICMP, that is your Internet Control Message Protocol packets, to determine the performance of a connection between devices. What is it used for? For determining the connection between two or more devices. I simply ping your device or I simply ping anything. Let me show you. So I'm again opening my command prompt, and the command for ping is also ping, but it uses a protocol that is called your Internet Control Message Protocol, that is your ICMP, right? So for say I want to ping www.whitefortress.in. Okay, so here you can see it will give the IP address of the whitefortress.in. Also here you can see I am receiving the reply from this IP, that is and this website www.whitefortress, this domain subdomain is hosted on this particular IP address. So here also you can see packets sent 4, packets received 4, packets lost 0. That means whatever the host is, whatever I'm pinging, I can either put a host address over here or I can put the IP address over here, right? So you can just ping either way. So for example, I want to ping some system, that first I am pinging my router, that is 192.168.0.1. This is the IP address of my router. And here you can see I'm getting the reply from it. Either I want to ping google.com, I'm going to get reply from it, right? So this is how your ping thing works. So if the host is reachable, it will show sent 4, received 4, lost 0. That means the connection is reliable, the host is reachable. But If I am sending, I am pinging some random thing. Okay, I am just pinging something called nothing.com. I hope it's not a thing. Let's see. Okay, there is something called nothing.com as well, I think. But it showed me the IP address, but request timeout means it is not reachable. Nothing.com is doesn't exist or is not reachable. So by default, ping sends 4 packets. Okay, by default, pinging sends 4 packets. Guys, please like the video. And if you have any doubts, you can directly ask me in the chat. I will be really happy to answer all your questions, guys. So here you can see nothing.com doesn't exist or is not reachable. So packet sent 4, received 0, and lost 4 means 100% loss. That means the connectivity, the host is not reachable, host is not reliable. More the packet loss, the less reliable the host is. So that's it. With the help of this, we can also know the IP address. Like for example, if I'm pinging a particular host, I will also get the IP address of that thing, whatever host I'm pinging, right? And okay, I told you by default there are 4 packets, right? If I want to send more than 4 or just 1, 2 packets, how will I do that? For that, we have a flag that is -c. Then I am putting 2 over here. Um, Let me check the flag again. It could be N2. Clear. Okay, it's -n. CLS. -c is used in then Linux, okay? You can just check the commands by -help. And in this, you can simply check it by using question mark, /question mark. Okay, with the help of /question mark, you will be able to see what flags could be used. -n is using for the number of packets sent. So I'm simply putting ping -n and then whatsoever my host is for say White Fortress .n. I forgot to give the number of packets. So I want to send only 2 packets. Okay. So here you can see I put ping and then whatsoever my host is and then -n 2, 3, 4, as many packets you want to send, you can mention over here after the -n flag. So here you can see it only send the two packets. Here you can see send to, receive to, loss 0. So this is how you can send 1 or more packets. Ping uses Internet Control Message Protocol packets to determine the performance of a connection between devices. It determines how good the connection is, how reachable the connection is. For example, if the connection exists or is reliable or used to test the reachability of a host on an internet control network. So, on an IP network, it is used to test the reachability and reliability of the host. Next, this is an activity, simple activity. You try to ping google.com. What will be the command for pinging google.com? This is, right? So on your system, you try to ping google.com. Okay, just open your command prompt, just type the command, and to clear the page, the command is CLS. Okay, if you want to clear the page, for that the command is CLS. So try this on your own. Moving to the next protocols, these are some common protocols that you should know about. Okay, so telnet is used for remote connection. SSH is used for remote connection, but this is more secure than the telnet. The connection is encrypted in the SSH, whereas in telnet the connection is unencrypted. Then we have got FTP, that is your file transfer protocol, and it is used for file transferring. You should know all these protocols, at least minimum these protocols should be known to you. Also on which port they are on, they are at, and their description means what are they used for. Okay, these you need to know. Then we have SMTP, that is your simple mail transfer protocol, used for mailing, used by mail servers to like for example, if I want to mail you, this is the protocol that my system will be using. Next, we have SSL, that is your um, secure socket layer, that is used for encrypting the data. Hello, good morning, Hugh. Welcome back. No problem. Then we also have TLS, which is the older version of SSL. And we have got HTTPS, VoIP, SNMP. You should know about all these protocols and the port numbers they are at. Next, we have got TCP, UDP. This is very important. Listen very carefully. TCP and UDP protocols are also known as transport protocols because they work at the transport layer in the OSI model. Okay, we will discuss the OSI model later. After all this theory part is covered, then we will get to the OSI model and then we will start the practical part. So TCP and UDP protocol, in TCP and UDP protocols, they work at the transport layer and used for transferring data from one system to another system. Good morning, Patel ji. Welcome back to the channel. I hope you guys are doing good. And if you got any doubts, any questions, you can ask me right away in the chat box. So let's take an example to understand the working of TCP. So for example, there is one girl, Alice, and there is a guy, Bob, and then Alice wants to send some data to Bob. Okay, so first of all, Alice is going to check if Bob can hear Alice or not, if it is available to receive the data or not. Yes, T, how are you? I am also good. Hume, I'm doing good. Just caught up in starting my institute offline. So I'm just busy with that for the time being. And then classes, new batches are going to start as well. Let's begin. Next, we have got Alice. Then, hi Bob, can you hear me? It asks the Bob, hi Bob, can you hear me? She is checking that if Bob is reachable or not. Then Bob says, hey Alice, I can hear you. Bob acknowledges that you are reachable. Alice, you are reachable. Your messages are reachable to me. Can you hear me? My messages are reachable to you or not? Bob asks the Alice. Then Alice says, yes, you are also reachable. Now let's talk. Means now whatever data they have to share, they will start sharing the data. So what happens at the client and server side? For example, client wants some data from the server, some kind of file or anything. So first of all, client, that is your browser, synchronizes with the server and asks if I am reachable or not. And if the server is reachable, then the server will reply with SYN ACK packets. That is, acknowledgement means yes, you are reachable, and SYN means am I reachable from the server side. Then client replies with the acknowledgement that yes, you are also reachable. So this is how the TCP works. It has to make connection first of all, then only they will start sending the data. They make sure that the data is reachable, each and every packet is reachable and in a sequence. But what happens in the UDP? In UDP, whosoever client or server requests the data, whatever the request is, and then the other party starts sending the response. They do not care if the connection is maintained or broken. They just have to send the packets continuously. Okay, till the data is reached or the full file is reached, or not file, I will say. Like for example, in your video calling, this UDP protocol is used. So let's see. TCP keeps track of lost packets. Make sure that lost packets are reset. So your TCP keeps track of lost packets means it first of all makes the connection at the both ends. What whoever the sender and receiver is, first of all the connection is established, and if any packet, so they add the TCP protocol add sequence number, so the packets will be going from one end to another end in a particular sequence. And also If any packet get lost, then the packet will be resent from the sender side. But in UDP, it doesn't keep track of any lost packets and doesn't add any sequence number to the packet. So it do not care about the packet arrival order either. So add sequence in TCP, it adds sequence number to packets and reorders any packet that arrive in the wrong order. So TCP is slower because of all the added additional functionality, and UDP is faster because it lacks any extra features. TCP is slower because it has to check if the packets are lost or not, and if packet is lost, it will resend, it will check the sequence, it will consume a lot of operating system power, right? It will use a lot of computer resources. So that's why it is a slower protocol, whereas UDP is faster. Both are equally important. There is nothing like a TCP is better than UDP. No, they are used for their own purposes, they are used for their own works, and both are self-efficient in itself. Next is your TCP requires more computer resources because the operating system needs to keep track of ongoing communication sessions and manage them on a much deeper level. So your TCP also will be using the operating system resources, whatsoever your computer resources are, and will keep managing the session at much deeper level. But in UDP it requires less computer resources because it do not have to have any other functionalities like these, right? So TCP is used by protocols like HTTP, HTTPS, FTP, and many other computer games, and your UDP is used in IP telephony system. Like right now I'm broadcasting, and that is the packets sent to you are in the UDP format. So DNS in also in DNS, DHCP, your UDP protocol is used, and in many computer games, which are live games, right? Like your Free Fire, your Valorant, those kind of games uses your UDP protocol. So next topic is topologies. So this is also important and also asked. So these questions, like you're seeing the TCP versus UDP, and what are topologies, what are types of topologies, these are the questions which are also asked in the interviews. Okay, I hope I'm clear to you. And guys, also like the video. And now topology and network topology is the physical and logical arrangement of nodes and connections in a network. So this is it simply tells how in a particular network, in a physical network, like you are sitting beside me and then some other person is sitting beside us, like all the devices are connected together, and ultimately with the wire, with the cable, they are connected to the switches, then to the router, then ultimately to the internet. So there are multiple, in a single location, there are multiple systems that are interconnected with each other, either with the use of hubs, switches, or directly with the help of cables. Okay, so a network topology is the physical, okay, physically how they are arranged in a location, and logical arrangement of nodes and connection in a network is called your network topology. Nodes usually include devices such as switches, routers, softwares with switch and router features. So, what are nodes? Nodes simply means your devices that are present in a particular network, like your PCs, your routers, your switches, your hubs. We'll be talking about all of those components of network in very detail. So let's talk about network topologies. So first is your bus topology. Ring topology, star topology, mesh topology, hybrid topology, tree topology. These are the topologies that we are going to discuss today. Coming to the bus topology. In bus topology, one long cable acts as a single communication channel, and all the devices are connected to this cable. So what happens? There is a long cable and all the devices are connected to this cable. So for example, this system, the top right system wants to communicate with the top left system. So what will happen? The packet from this system will start moving to this system, then it will go to this system, then it will go to this system, then ultimately reaching here. So the packets are broadcasted. The packet from one system will go to the all other packets present in the same network. So this is a simple bus topology. Okay, so what are the advantages of it? One, require only single cable to connect multiple devices. Okay, so it is easy to add and remove nodes in a network because just have to add a cable to the cable, that's it, right? It is less expensive because there are no external devices used like hubs, switches, nothing is being used. So it is less expensive. Next, it broadcasts the message to each device which are connected through the cable. So just like I told you, it broadcasts from this system, it will broadcast to all other systems. It will go to the all other systems. But all the other systems like this one, this one, this one will drop the packet, and only the this system will receive the packet because it was meant for this one only. Because I told you packet contain a packet's header contain information like source and destination IP address, source and destination MAC address, and their port numbers. I hope this thing is clear. And guys, if you got any doubts, if you're not getting anything, you can just tell me in the chat. Or also you can comment it, or contact us on the number that is given in the description below. So advantage, it is less expensive. It broadcasts the message to each device which are connected to the table. It is easy to maintain, and in case of any computer failure, there will be no effect on other devices. So for example, one system fails. So others are directly connected with each other with the help of the cable. So there will be uh, no problem to the entire network. Only the system has failed, only this system got the problem, but entire network will work correctly. Next, we have got disadvantages. If backbone cable fails, then the entire network will be failed. Obviously, there is only one cable that is helping the entire network connect with each other, right? So, if the backbone cable fails, the entire network will be failed. The messages are broadcasted, so cannot send the private messages. All the messages are broadcasted, so there is less security and private messages could not be sent. It takes more time to pass the message from one place to another place because the packets are going through each and every system. Just like I told you, from here the packet will move to this one, then will this one, then this one, and it will keep on broadcasting like that. So it takes more time from reaching one side of the network to the another side of the network. The length of the cable is limited, so not it is not very scalable topology. In bus topology, if something happens to the cable, would it break the entire system? Since there is only one cable managing all the devices, yes, that means full network will be failed. Here also you can see if the backbone cable fails, then the entire network will be failed. So next is the length of cable is limited, so it is not scalable. Not many devices can be added. In this topology, data is transmitted only in one direction. Okay, so the data is transmitted in one direction, or the data collision will occur. Data will collide, packets will collide with each other if the data is not sent in a particular direction. Next is your ring topology. It is called ring topology because it forms a ring in shape. Okay, here you can see the devices are connected with each other adjacently. In this topology, each node is strongly connected with its adjacent node. So this is how the packets move. Okay, they also move in a single direction. They do not move in bi-direction. The packets do not move bi-directionally. They also move in the single direction in this topology. So it forms a strong network, and the packets are sent very quickly. So each on every node can share data with another node connecting through a ring topology. So if this system wants to send packet to this system, it will go from here to this system, then this system, then this system. Okay, this is how it will work. It will not go directly to this system. If the packets are moving in this direction, then it will first travel through all the other devices, then only it will reach this system. Okay. Um, where we were, just a second, ring topology here. So transmission rate of data is in high speed. The data is travel in very high speed in this topology, and the data sent through ring topology will be broadcasted too. Hello Arjun, welcome back. We started ring topology. Sorry, we started with the topology. What is topology? That is the physical arrangement of devices in a particular network. And before that, we covered the difference between UDP and TCP protocol, which is also asked in your interview questions. Also, this is also asked in your interview question. What are topologies? What are the types of topologies? So we are covering this one currently. Okay, let's get to the disadvantages. It is very difficult to it is very difficult task to add some new computer, because just imagine I want to add a fifth computer over here. Okay, so what will happen? I will have to like shut down the entire network, then only I can add another network, right? So it is very difficult to add some new net computer to a network, to the ring topology network. So if we want to send data from a source to destination machine, then data will unnecessarily pass through all the nodes. The data will move from one system to another, then another, right? Just like I told you, from like this is how the systems are connected, and this system wants to send packet to this one. The data will flow through these two systems as well, because this is how the packets will be moving. So coming back to here, it is very difficult to recover the ring topology if any particular machine is not asking properly or working properly. So what happens if a particular system fails? The entire network will fail. Okay. And because of that, it will be very difficult to diagnose the like where is the problem at this end. Okay, for suppose the problem is at this end, but we will not be able to identify if it's here, 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 or where, right? So in ring topology, it is very difficult to identify where the problem is, and to again diagnose and uh, get the, if one machine is compromised, wouldn't it put every other system on risk? Yes, these are very, very insecure network. Bus topology, ring topology, and star topology, if we are using hub, it is very, very uh, insecure network. Arjun, you're welcome. No need to say thank you. Okay, let's continue. Let's get to this one. And we cannot send private messages because packets are going through all the networks, so the packets are being broadcasted. Next, we have got the star topology. In star topology, all the nodes are connected with a central device called hub. Either the device will be connected to the hub or will be connected to the switch. Okay, because hubs and switches are used instead of connecting it directly to the router. Why it is connected to hub or switches? Because if I have got like 25 computers in a network, in a single network, but router has only got like 3 or maximum 5 ports. Okay, 2 to 5 ports are maximum number of ports that are available in a single router, in a normal router. Okay, so if I want to connect 25 devices to the router, how will I do that? It's not possible, right? So that's why we have devices like hubs and switches, which have got multiple number of ports to connected multiple devices together. So in star topology, all the nodes are connected with a central device called hub. The sharing of data is only possible through the hub. So for example, this device wants to share data to the hub, to this system that is in the opposite direction. Okay, so this system wants to send data to this system. So what will happen? The packet will travel from this system through the hub first of all, and then only it will be passed to this system. But let me tell you one thing. If we are talking about hub, what happens with the hub? It broadcasts the all the packets. It means if the packet is sent to this particular port, okay, just giving an example, the packet is sent to the uh, right, most right port. Okay, so what will happen? Or this packet will be copied to all other ports and then will be broadcasted. But if it is switched, then the packet will not be broadcasted, will be only sent to the port connected to the receiving device. Good morning, ma'am. These red dots are cursors. Blue dot is confusing me and giving me ADHD. Sorry, sir. Just do not look at it. You already know all this. You just ignore this one and do your work. Do not disturb me. I'm sorry about this one. Okay. I don't want to be mean. Okay, let's continue. So if the packet comes from here, it will be broadcasted to all other, but other devices will drop the packet, and only this device will receive the packet. So what are the advantages? It broadcasts the message. Okay, so if it is hub, it will broadcast the message. If it is switch, it will not broadcast the message. It is less expensive due to less cable. Less cables are used. Hubs are not very expensive. They are like 100 to 200 rupees at cost. Sir, do not cry, please, not in the chat. Okay, easy to connect new nodes without affecting the rest of the network. Okay, new nodes can be easily connected because hub and switches got multiple ports. If one node failed, then it would not be failure of the entire network. So for example, there is one particular system that is not working properly, entire network will still work well. Next, what are the disadvantages? In star topology, we must require a network device like hub or switch. Obviously, we will need something like hub or switch. If two nodes want to share the data, sharing is only possible through hub. If the hub fails, there will be no data sharing from one system to another. And we cannot send private data if we are using hub. But if we are using switch, then we will be able to send the private data as well. Next, we have got the mesh topology. In this topology, each and every computer is directly connected with each other. So we can directly send data to the destination machine without going to intermediate machines. Okay, so guys, please like the video as well. So for example, this is a particular system and there are multiple systems present in the network. So it will be directly connected to all other systems with the help of the cables. Okay, so with the help of cables, it will be each and every device will be connected to every other device with the help of cables, making it look like a mesh. It will be very messy to implement in the real life, obviously. So we can directly send the data to the destination machine without going to intermediate machine. And there is no intermediate machine like hub or switch being used. Next is advantages. It is very good topology to send the private message. Okay, so it is very, the messages are sent directly, so we can send private messages in it. All the nodes are directly associated with another node, so it provides point-to-point connection. So what does it provide? Point-to-point connection because each node is connected to each other. We also call it point-to-point connection. If someone asks you what is P2P, that means all the devices are connected with each other, point to point, P2P. We also call it P2P. Is this how schools and offices are set up their system? It depends. Honestly, it depends on them. They can connect it however they want because that looks messy. मेसी मेरे स्कूल में तो बच्चे माउस चुरा लेते हैं पीसी में से. It's a different thing. Connecting like keyboard or mouse is something different, but connecting the systems together and ultimately to the router, that is a different thing. होता है, हमारे स्कूल में तो नहीं होता था, हमारे स्कूल में तो बहुत खौफ था. टीचर्स का। हाँ, मेरे को भी जानना है कौन सा स्कूल है ह्यूम। So unlike ring topology, if a particular machine is failed, then entire network will not fail. Okay. Multiple devices can send or receive data simultaneously with each other. Okay, so if this want to send data to this, then this, whatever, whosoever wants to send data to other system, they can send it simultaneously. They do not have to wait, or there will be no data collision. I hope this term is clear to you. What is data collision? Means in a single cable, two devices are sending data to each other simultaneously, and then the data collides, those packets collide with each other, and there is loss of packets. That is your data collision. ना KVS बेकार स्कूल पागल बच्चे सारे. Okay, okay. So, what are the disadvantages? It is very difficult to add some new node because each and every computer is directly connected with another one. So, there is, so suppose I want to add one more system. So what will I have to do? I'll have to go to the all other systems, and I'll have to connect my system to all other devices that are already present in the network. So it will be very, very difficult to add a new node because each and every computer is directly connected with one another. If a particular machine is not working properly, then we can't send or receive data from the failure machine. Okay. So obviously, if a particular machine is not working properly, then we cannot send data only to that machine, but the whole network will work fine. Next, we have got hybrid topology. In hybrid topology, हमारे स्कूल में पीसी जैसा कुछ था ही नहीं. This reminds me of torrents. But sir, you have got a great PC at your home. You should talk about that one, not about your school ones. This reminds me of torrents, but I guess not. Okay, so hybrid topology, combination of various different topologies is called hybrid topology. So we have got here, you can see, we have bus topology, right? This is bus topology, symbolizing bus topology, and here we have got ring topologies. So one or more topologies, when are used together, are called hybrid topology. So we have also got tree topology, which is also a kind of hybrid topology. So what does tree topology do? In tree topology, you can see it. There is what bus topology and star topology, and it looks like tree. It looks like branches of tree coming out, and here you can see in tree topology, this is bus topology, a backbone cable is connected, and then concentrator. What is your concentrator? Your hubs or switches are connected to the cable, and then ultimately to the other devices like your clients, your PC, your laptop, and your printer. These are all the end devices. Okay, I will talk about the what are end devices, what are intermediary devices in the upcoming video lectures. So let's get started with tree topology. In this topology, all the nodes are connected like branches of tree. And it is the combination of bus and star topology. Just like I told you, this is a backbone cable, and then ultimately these are some star topologies connected to it. So I hope what are topologies, it is all clear to you guys. And please take the screenshot of this one. You should know all these. Okay. So someone asks you what are topologies, you will say it is the physical and logical arrangement of devices in a network. Okay. What will you say? What is a network topology? Is the physical and logical arrangement of nodes कह लो, devices कह लो. Okay, you can say nodes or devices either way. It logical arrangement of nodes, connections in a network. So this is what you're gonna say. And what are types of topologies? Bus, ring, star, mesh, hybrid tree. They are very easy. I hope you just remember them. because we discussed all of these in detail, in very detail. Let's continue. Now we have got some network configurations. We have got P2P, that is your peer-to-peer model, and client-to-server model. You will see these terms very often when you will be studying networking or something related to that. Peer-to-peer model and client-to-server model. Let's see. Let's start with the client-server model. Okay. So we have got the client-server model over here. You can see we have got server, we have got multiple clients. So what are the clients? Clients something that we can put input into and we receive output onto, right? So my mobile phone, my laptop, my PC, everything is ultimately connected to the internet. Then I want to reach some particular server like www.google.com, whitefortress.in, any server I want to reach. So let's discuss. It is a configuration of computer network include a server and one or more clients. So this in client server model, there is at least a server and one or more clients available. And they could be connected directly with the cables or through the internet. So client manages local resources like CPU, keyboard, monitors. Okay, so here you have got your PC. So it manages normal things like your local resources, CPU, keyboard, monitor stuff. But server has got the main power. It is more powerful. Torrents work on P2P model, right? What's the master and a slave? What's a master and a slave system? I have heard about it, but I have never heard about master and slaves. Okay, master and slave system is AD, your Active Directory, I think. Master and slave refers to the relationship between controlling entity and the subordinate um network. Master and slave architecture. Let's see. Master, slave, save, data read, data write. We'll get back to that topics. So, a master and slave architecture, a computer system known as master and slave architecture involves single central unit referred to as master, and that governs and guides the activities of several slaves or subordinate units, and they report back to the master architecture commonly used in distributed systems to manage resources efficiently and streamline data processing. Okay, so for example, you have got a database. Okay, so do you know what are distributed database? There is shared databases and there is one thing called, I forgot, there are shared databases and there are not shared databases, something I forgot the name. So what happens in the distributed databases or shared databases, um, there are multiple, like for example, I have hosted my website www.whitefortress.in on a particular server. Okay, so there are other websites also hosted on that particular server, like for example, something like indeed.com, something like what do I say, any other, like for example geeks4geeks.org. Okay, something like that is hosted on what, a particular system, on a particular server. Okay, so it has also got multiple other websites going on the same system. So here you can see there is a single data. So the server has got multiple databases, and in the databases there are multiple websites ultimately hosted, and other websites might have their own database. Like for example, my site has got this database, then another site like indeed.com got this database. So they have got something like this. So what happens? Only the main database, the master database, can be read or written by the authorities, but the other databases could not be. Okay, even if we change the databases of our end, this is all reported back to the master database and ultimately to the owner of that particular server. I hope this thing is clear. Communication between the master and slave nodes is generally unidirectional, with the master using commands and the slaves executing them. Okay, this is something even different. The architecture enables parallel processing and load balancing. Also, we already talked about the load balancing thing in the ethical hacking part, that for example, I have got a single database and my all the data is given to that database, and I'm simply uh, putting all the data in it. And if someone tries to do a DOS attack on it, okay, someone tries to send requests, so many requests on it, which my database cannot handle at all. So other databases connected to it, it can send half of the packets to the other databases connected to it. So it ultimately helps in the load balancing as well. As, as tasks can be distributed across the multiple slaves node, thereby improving system performance and scalability. So you can read it over here as well, Hume. Okay, even I heard about it for the first time. Let's continue. I know about load balancer and everything though. Okay. So clients manages local resources. But what does your server do? Server is more powerful than client, which manages shared resources like databases, printers, etc., and handle all incoming requests for its share. So what does your server do? It is more powerful than the client. It has to has to manage everything like shared resources, your databases, your printers, whatsoever is connected to the server, and have to handle all the incoming requests from all the clients across the huge network. Okay. Now, next we have is P2P model, peer-to-peer model. So in P2P model, each party have same capabilities. So here we have got no server at all. All the systems have got data in them, and they can start sharing data from one side to another side whenever they want to initiate the communication session. And there is any party can initiate the communication session. So not always the data is stored in the servers. Sometimes it is stored in a particular folder in your systems. Okay, so in this model, user can use the internet to exchange files directly with each other. So anyone can become client, anyone can become server. So for example, this wants to request data from this system and it has got some database. So it will start asking for the data or the file folder, whatsoever it needs. So it will start asking from this system. So in this case, it will become the server and this will become the client. Whosoever is providing the data is server and receiving the data is your client. So here they have got similar the capabilities, and there is no authority. So this is very unreliable network as well. So what are the advantages? It is easy to set up. It is less complex because all the devices can directly communicate with each other. Then lower cost because network devices and dedicated servers may not be required. So there are no dedicated servers. Okay, we call them dedicated. There are two types of server, dedicated servers and distributed servers. Okay, that's what I wanted to say. May not be required, can be used for simple tasks such as transferring files and sharing printers. So it could be used for simple tasks like transferring files and sharing printers with each other. What are the disadvantages? There is no centralized administration, means not secure, not scalable, and all the devices may act as both client and server, which can slow their performance as well. Guys, so many people are watching. Please like the video. And also, if you have got any doubts, any questions, you can ask in the comments in the chat section. Client server mod. Okay, this is done. Now we are going to talk about types of network. So in types of network, we have PAN, LAN, MAN, WAN. PAN is your personal area network, LAN is your local area network, MAN is your metropolitan area network, and WAN is your wide area network. So PAN, full form, personal area network, connects electronic devices within a user's immediate area. So for example, right now, I've got a Bluetooth mic, I've got a phone, I've got my earphones, everything connected to each other. Like for example, my earphones are connected to my phone, my mic is connected to my laptop. Okay, things like that. So it is it ranges from a few centimeter to few meters. So you cannot, if I want to connect Bluetooth to my PC, I cannot take it very far away, right? If I want to keep it connected, so for that, I'll have to stay in range from a few centimeters to a few meters. Otherwise, it will not work. So this is also example Bluetooth earpiece plus a smartphone connected to each other. That is the example of your PAN. Here also you can see printers ho gaye, printers connected to the PC, mobile phone connected to your Bluetooth, and your laptop connected to your headphones or your earphones, mouse, wireless mouse are also available these days. So this is a PAN. Next, we have LAN, that is your local area network, is a collection. Okay, one more thing I want to say. In types of network, there are multiple. Okay, you have got campus area network, you have got server area network, and things like that. So, but these are the main ones. Okay, there are multiple types of network as well, but PAN, LAN, MAN, WAN are the main ones which are asked usually. So sometimes interviewers also ask what is LAN, what is MAN, what is PAN. Okay, things like that. What is WAN? So this also comes in interview questions. So LAN is a connection of devices connected together in one physical location. For example, a building, office, school, or home. So LAN can be as large as your full building and all the devices connected to each other, and as small as small office network, small home network, where only 5 6 devices are connected with each other. So that is your LAN. So whatsoever, like for example, my router is connected to the internet, and other my devices in a particular single physical location is connected to the router. So this part will be the LAN part, and on the other side of the router will be your WAN side, wide area network. We will be talking about wide area network in a while. So left side of here you can see this is the LAN network, which is my private network, and on the right side will be the WAN network. That is your wide area network. So MAN metropolitan area network. So multiple LANs like hospital LAN, college LAN, factory LAN, school LANs, all connected together forms a MAN. That is your metropolitan area network. Computer network that connects computers within a metropolitan area means it could be as which could be a single large city, multiple cities and towns, or any given area with multiple buildings. So it could be multiple lands connected across multiple cities, towns, and a MAN is larger than a local area network. Of course, it is larger than a local area network and smaller than the WAN. That is your wide area network. So wide area network is a technology that connects your offices, data center, cloud application, and cloud storages all together. So what happens is WAN, like for example, I uploaded a video on the YouTube channel. Okay, so ultimately, where that video is being saved? At cloud. What is your cloud? not something in the sky, but those are the data centers, right? So for example, I am accessing that video. I want to download that video from from YouTube, right? From YouTube, I want to download that video from my to my system. I'm sitting at the office and the video is at the data center and I'm downloading it from there. So my office connected to the data center in a way, my office network connected to the data center somehow, and ultimately to the internet. So WAN is a technology that connects your offices, data centers, cloud applications, and storage all together. Cloud storage all together. And it spans beyond a single building or large campus to include multiple locations spread across a specific geographical area or even the world. So I am like from here at the office in the Delhi, India, Delhi, and I am accessing the data centers data, and in data centers you usually have servers and which store the data, videos and everything, and that data center might be in the Singapore, right? So different geographical areas are connected like this with the help of WAN. Next we have got some wireless network connectivity like your GPS, your Wi-Fi, your Bluetooth, your NFC. So we already know about GPS, Wi-Fi, Bluetooth, and NFC is something, might be something new to few of you. Is there any authority which administers MAN, or is it just the ISPs? No, there is. I will not say there is any authority. It's just we connected. Like for example, from school I'm no from home LAN I'm able to connect to my college LAN. Okay, I'm able to access the devices at my college. That's it, means connectivity. There is no administrators, I will say. Or is it just ISPs? No, it's just connections for how far we are connecting to the network. That's it. Like what kind of security is there, since even hospitals are connected to it? Look, overall, all these LANs are connected to the router and ultimately to the internet. But sometimes what happens, like for example, there is a particular company, they have got its own college, they have got its own factory, school, and hospital, everything. There is a organization, for example. So it took a specific IP. Just like I told you, there are class B IPs that are used by the large companies, right? So that organization took the class B IP for say, and they have connected those. And the same IP is used in the hospital LAN, college LAN, factory LAN, school LAN of their own. I hope this thing is clear to you. Means they are connecting the LANs together with the same address. Is it clear? It's not necessary. It might be the same network, it might not be the same network, but ultimately they are just getting connected. There is nothing like security or something. Security is configured in your routers, in your firewalls, that might be configured at a particular LAN. Okay, so there is no security outside the LAN if we talk about it. Okay, internet service providers also provide some minimal securities, but main is that a hospital LAN might have firewall, might have routers configured very well. Colleges also, factories also, school LAN also. That is what the security is. Multiple intermediary devices that are configured securely. That is the only security available on the internet. Okay, same as in the WAN. Like for example, I have put some security in my office. Like I have got firewall, I have got switch, I have got my own device has got antivirus, right? That is also a kind of security that is in the particular network. Then at the data centers, there are very so many firewalls used, and multiple things are used. Like even cloud security is being employed in the data centers, right? So separate areas have got their own uh, level of security. So anyone outside the network can connect, right? Like with anyone with a different IP won't be able to access their network. Look, I will not say not access the whole network. I am just getting some data from it. Like for example, I am going. Look, what is my IP? Okay, what is my IP? This is my IP, right? This is my IP address. But then I'm going to www.whitefortress.in, right? I am also accessing the data in some way, right? I'm just accessing the data in some way. But what is the IP of this one? Let's open the Shodan and check the IP. This is the IP. But I'm still able to access the website that is hosted on this particular IP, right? So this is how it works. No, ma'am, can you repeat man and van? Okay. Look, do not do not get confused with it. It's just how your networks are connected with each other, how your devices are ultimately connected with each other. Just a second. I have got एक second देना. Okay, let's continue. So, I talked about LAN, then man. So, for example, let's talk about a single LAN. So, it has got the router, it has got multiple devices in it. Same in the college LAN, same in the factory LAN, same in the school. And if I want to connect anything like factory LAN to the college LAN, okay, anything means I am communicating with this from this network to this network in a specific in like college is in another city and factory LAN is in other city, and I want to communicate, make them communicate with each other. That's it. Two LANs connected together, trying to communicate with each other or asking for data from one side to another side. That's it. So it is computer network that connects computers within a metropolitan area, means at a larger area, like cities, multiple cities, towns, or even a given large area with multiple buildings. Or for example, I have got a society for say, okay, and there are multiple buildings in it, and all the buildings network are ultimately connected to a single central unit that is and able to like I'm able to access the data of one building, another building, then fourth building, something like this. A man is larger than the local area network but smaller than the wide area network. So WAN was your wide area network is a technology that connects your offices, data centers, cloud applications, and cloud storage all together. Means from here, I'm able to access the data that is uploaded on the cloud, that is already uploaded on a particular website or anything. And ultimately, all that data is stored in a some data center, maybe some in other city, in some other continent, who knows. It spans beyond a single building or large campus and includes multiple locations spread across a specific geographical area like different countries or even the world. Is it clear to you guys? Or still you have got some questions you can ask me. So we have got wireless network, device like technologies, wireless network, technologies I would say. We have got GPS, Wi-Fi, Bluetooth, NFC. So what is GPS? We all know Global Positioning System. It uses satellites to transmit signals that cover the globe. The smartphone can receive these signals and calculate the phone's location to an accuracy within 10 meters. Okay, so within 10 meters, it works fine, but it might or might not tell the exact location of the device. Next, we have Wi-Fi. We all uses Wi-Fi, and there is one definition of hotspot over here. That's what I want to tell you. Wi-Fi transmits and receivers are located in the smartphone. Obviously, they are located in the smartphone, and also in your multiple devices like laptop, tablet, etc. The phone to connect to local. And please, one more thing, guys, do not like get complexity over these man van things. Just know this is your local area network in a single physical location, building, office, school. This is your man connecting multiple lands together in multiple city and town. That's it, all you have to learn. And simply WAN, which connects your multiple uh, which connects across a specific geographical area or even the world. Example, your offices, data centers, cloud applications, cloud storage, all connected together. That's it. That's all you have to learn. Okay, do not get a complexity over this thing. These are just very simple definitions. This is not as complex as it looked. Okay. Next, we have got GPS. We already done with this one. Wi-Fi. So, in order to receive and send data on Wi-Fi network, the phone needs to be within the range of the signal from a wireless network access point. So, it has to be in the range. Like, for example, my device is connected to Anj 5G something, right? So, it has to be connected uh, to the wireless network access point, and Wi-Fi network are usually privately owned but often provide guest or public access hotspot. So if you go to the cafes, there will be public Wi-Fi is also available. So what is hotspot? Hotspot is an area where Wi-Fi signals are available. Okay, so we say na just turn on the hotspot in your mobile phone. What does that mean? It is just hotspots definition is an area where Wi-Fi signals are available. So Wi-Fi network connections on the phone are similar to the network connections on a laptop computer. So how it works in phone is similar to how it works in your laptop, in your tablet, or any other device using Wi-Fi. Next, we got Bluetooth, which is a low power wireless technology, and it connects multiple devices like speakers, headphones, smartwatches over short distance to your devices. It supports both data and voice transmission and allows multiple devices to connect simultaneously. We all know what is Bluetooth, right? Next, we have got NFC, near field communication. What it is used in payment systems. You know about metro, right? In metro cards, you have to just tap it on the system, whatever that NFC system is. You just have to tap your card on that metro enter and exit system, right? So that thing also use near field communication is a wireless communication technology that enables data to be exchanged by devices that are in very close proximity to each other, usually less than a few centimeters. So we have to move the card very close to the. Okay, you have got a question here. Just one more question. For example, if a big company has offices, could they configure MAN to only connect it to their own systems? No, it could be connected to a public network as well and not allowed any outside connection. No, no, no. Any outside network connection will also be available either in the LAN or in the MAN or in the WAN. Okay, they can connect multiple devices across the internet. It's just about configuring them like a VLAN. No, there is nothing like VLAN in the LAN MAN WAN. VLAN is completely different. That is your virtual LAN. We will be talking about that in the upcoming lectures as well. Okay, there is a complete topic called VLAN that is in the practical part of this one. For now, we are covering the theory part, which is very essential to go with the practical part. Okay, am I clear to you, Hume? And guys, do like the video and let's continue. Also, if you got any doubts, you can contact me on the number given in the description below. So let's get to it. Okay. And if you still got any questions, I'll be happy to answer you all, no matter how many questions you have got. Okay, I'll never get tired of your questions. Don't worry about that. Near field communication is a wireless, okay. For example, NFC can be used to connect a smartphone and a payment system or your card. You know that, na? Your card to your uh, metro check-in and check-out system. So NFC uses electromagnetic fields to transmit the data. So how the data is transmitted? In the electromagnetic fields. Now getting to the components of network. This is very important. Listen very carefully in this one, okay? So we have got end devices, intermediate devices, and network media. So for example, this is a single network, okay? We have got routers in it, ultimately connecting us to the internet. We have got multiple clients. What are the clients? It might be your mobile phone, it might be your laptop, it might be your PC, it might be your tablet, anything. Client is simply something if we are putting our input in or getting output out of. Okay, your browsers, your mobile applications, all are clients that are connecting you ultimately to the internet. So we have got servers over here. We have printers. Servers and printers are also end devices because it also gives out some output. Printer gives out some output after we give input into it. Servers also receive input and output and gives out output. We have got hubs, bridges, repeaters, and routers. These devices, router, bridge, hub, repeater, these devices only do one thing, that is to transfer data from one side to another side in a network. Okay. So these are called intermediary devices. Devices that just send data from one end to another end are called intermediary devices. Okay, so off topic, but I'm actually curious, could we configure or make a device which would mimic the NFC of a metro card? Engineers might know, okay? Engineers, like hardware engineers might know about it. I am not hardware engineer. I'm just into cybersecurity stuff, so I do not have any idea about it. But I have some friends which do such things, like building NFC technologies and things like that. Okay, it is possible to make technology like NFCs and everything, but that is the work of hardware engineers. Okay. Also, to connect all these devices, there will be some transmission media, right? Some network media, which could be either your cables or your wireless media, right? Your infrared rays, etc., etc. So, what are the example of end devices? Okay, guys, I have a question for you first of all. So, till now, whatever you have learned from me, if you got any questions, you ask that. And also, what is the name? What is the name of your what we call UDP? Okay, I told you about TCP and UDP protocol. I and I want an alternative name for your TCP and UDP protocol. Okay, what will be the alternative name for the TCP and UDP protocols? So that is my question to you guys. Okay, I want it in the chat box. I think there is a device which would be insane stuff like open car locks and stuff. It for that the flipper zero is used for opening car locks and stuff. Flipper zero is used. What happens in flipper zero? It like for example, some person is opening or closing their car, it will capture that code that is sent with that wireless remote, it will simply capture those requests. And after that person is gone, we can use the same code to unlock the device. For that, flipper 0 is used for opening and locking the car and stuff. Okay. So in example of end devices, desktop computer, laptop, printer, IP phone, wireless tablet, telepresence endpoint, these are the end devices. Next, we have got intermediary devices. In intermediary devices, we have wireless router, LAN switch, routers, multi-layer switch, firewall appliances. We will see all these devices in practical as well. So just stay tuned with us. Next, we have got network media. We have wireless media, LAN media, WAN media, etc. So end devices are node devices that serve as a source point or a destination point in the communication that occurs on a computer network. Okay, end devices either serve as a source point or destination point, right? Like for example, I am asking for some data from a particular server. So it will send the data back to the client over here, or when the client request will go from here to here, then server will respond, then it will go from here to here. So they are either source point or destination point of a communication session. So types, there are two types of end devices. First, end devices as client. Second, end devices as server. Client performs tasks of requesting data, displaying received data, etc., meant usually for usage by the end users. And sir is also telling the same thing, Hume. That device is flipper 0 and does a lot of things like NFC replication, capturing sub G. Yeah, that's what I was asking. Could it mimic a NFC of a metro card? Yes, I think so. Whatever, just interesting stuff. And guys, please like the video. Let's continue. So devices as client perform the task of requesting data, displaying received data, right? So it asks, like, client is your browser. For say your browser, it requests the data and it displays the received data whatsoever. Like for example, I requested www.whitefortress.in. Then it will display the received data, that it will show me the site open and whatever the content of that website is, etc., meant usually uses by, and I am the end user who will be using that end devices and giving some input into it. Then we have got end devices as servers equipped with programs that provide information and services such as your web pages, emails to other nodes on the or host on the network. So end devices as servers have got uh, all the web pages, emails, right? We have got web servers, we have got email servers, which have got all the information and services, and have ports open for a particular service. Like for HTTP, they will have a particular port 80. For HTTPS, they will have 443. For FTP, they will have 21. For emails, SMTP, they will be having 25 port number. Two other nodes, and also there are like SSH. For that, they will be having 22 port number. For telnet, they will be having 23 port number opened, right? So what the servers do, they just have some ports, and over that some set of rules which we call protocols are working, and ultimately providing us data or services, information or services. So TCP, transmission control protocol, also referred as connection oriented protocol, and UDP, that is your user datagram protocol, also referred to as connectionless protocol. Exactly, that's what I was asking for, Arjun. Yes, great answer. So your TCP has an alternate name that is also called connection oriented protocol, whereas UDP is also called connectionless protocol due to its own functionalities and features they have got. Okay, very correct, Arjun. Next, we have got intermediary devices. Intermediary devices are node devices that are designed to forward data from one side to another side in a computer network. Okay, so what does intermediary devices do? They just send data from one side, they have received the data and they will forward it to the another side. We have got, and it ensures the successful transfer. These devices keep track of information on the source address, destination address, or different pathways existing. Okay, so let's leave it. Let's take an example. So for example, I have got a postman. So for example, I want to send some data to Arjun. For example, let's say Hume. I know your name is Mayank, but okay, let's say Mayank wants to send some data to Arjun. So, for example, so Mayank tells the postman to send this XYZ package to Arjun. So, what will happen? Postman will take the data and will give it to the Arjun simply, right? Also, it will know where the data is coming from, means what is the source address. Also, it will know what is the destination address, right? Postman will know what is the address of Arjun's house or office or whatsoever, wherever that postman is delivering the messages. Okay, so also to take the package from Mayank's house to the Arjun's house, the postman will know several routes, right? So for example, one route is occupied, one route has got lots of traffic jam, but that was the shortest route. So what will the postman do? It will take the data from the longer route, right? Yet the most faster and the convenient route. So that is what your exactly intermediary devices like routers, switches do. So computer doesn't care. Okay, computer wants to send data to some XYZ, some device C at the internet, on the internet. So what will happen? Computer A will send the data directly to the router because it does not know who else to send the data to, right? It just knows that there is some device, device C on the internet, some XYZ device on the internet. So computer A will just send the data to the router saying that you send the device, send the packets to that device. Okay, so router, what will it do? It will work as a postman. It will take the data and then it will ultimately take the data to the device C on the internet through any route. It for each and every packet, it will decide the best route. It might be the shortest route. If the shortest route is occupied, then the longer route, yet the more speedy route, more convenient route. Okay, so routers does that with the help of multiple protocols that are being employed in it, that are being configured in it. So in the upcoming video lectures, we will also see what how router works, all in the practical, all in the Cisco packet tracer, and what are the protocols used in the router and how to configure those protocols. So coming back to the intermediary devices, I hope this will be clear to you guys now. So intermediary devices are node devices that are designed to forward data from one side to another side in a computer network. Ensure successful transfer, these devices keep a track of information on the source address, destination address, and different pathways that exist. Just like the postman knows what is the Mayank, then destination address, that was the destination of your Arjun, and the different pathways that might be used to deliver the package from one side to the another side in the network. So the network, through the network, depending upon the switching techniques being employed. So what are the switching techniques being employed? I told you na, the router uses multiple protocols or multiple functionalities to deliver the packaging. So those are the switching techniques, and we will discuss all in the detail in the upcoming video lectures. Also, it detects faults and errors effectively using redundancy bits. So for example, Arjun was not reachable, or whatsoever the address was, it was not reachable. So what will happen? Postman will send this information back to the Mayank that Arjun's home address is not available, or Arjun is not available at home. So postman returns us back to the package is returned back to the Mayank saying that that person is not available. So in the similar manner, your intermediary devices also returns back the packets, whatever the package is, with some added redundancy bits. What are those redundancy bits? Errors. Errors like there is 404, not available, 401, 402. We have already discussed all these responses, right? Arjun moved homes. Huh? Arjun moved homes? So provide network security by permitting or denying. Also, in intermediate devices, we have got firewalls as well. So if, for example, if some device on internet wants to send traffic to the device A, and there is a firewall, suppose this is not switch, this is a firewall, just for an example. So it has got some rules and regulations. The firewall have already some predefined rules, or we can also set some rules and regulations in the firewall. So for example, there is a firewall and it has got rules that computer A can send traffic to the outside network, to the internet, but cannot receive any data or any packets from outside network. Okay, so has been configured. So what will happen? Firewall will block the packets coming from the internet, but will allow the packets sent from computer A to the internet. So provide network security by permitting. So intermediary devices like firewalls also provide network security by permitting or denying the flow of data based on the security settings or security rules being employed. Okay, so I hope this thing is also clear to you guys what I was talking about. The so router also has got some basic packet filtering features. Okay, we can enable the access control list in the routers to ensure more security of our LAN, of our network. Okay, next device is hub. So hub, okay, hub is also an intermediary device. It simply has to send the packet from one device to another. Just a second. Yeah, this clears up what I was asking before. Okay, okay, that's great, Mayank. I hope all your doubts are clearing. Okay, for of all of you. And guys, please do ask the questions. Okay, I will be really happy to help you guys with all your questions, all your. Okay, let's continue. Guys, I need to add tags, to my video. Many people are not getting it. Ethical hacking got many views. Let's continue. So, what is hub? A hub is a networking device that is used to connect multiple devices in a network. So, of course, as I told you, router has got limited number of ports. We cannot connect each and every device to the router directly. So, for that, we need to use hubs and switches. So, this is what the first line describes. And hub works at the physical layer and broadcasts data to all the ports except the port from which the data is being broadcasted. So hub works at the physical layer of the OSI model, which is the layer 1 of OSI model. We will discuss the OSI model in the upcoming classes. Let's go. Okay. So for example, let me enlarge this. So for example, device 1 wants to send data to device 2. So what will happen? Hub So device 1 is connected to this port and device 2 is connected to this port. I hope this is visible. So the packet comes to this port. The packet from this comes to this port for this port. But what will happen? The hub will copy the packet coming from here to all the other ports. Okay, that's what I was telling you in the star topology as well. So the data comes from here and it will copy the data to all other ports. Then it will forward the data to all other ports. Okay, but if devices are connected to this port, they will drop the packet because it is clearly not for them. But this, when the data will travel from this port, it will receive the device 2 and device 2 will accept the data packet. Devices connected by hub cannot send and receive data simultaneously. So broadcast data to all the ports except from the port. So it will broadcast the data to all other ports, right? It will not broadcast it back to this port, but to the all other ports. It will copy the data to all other ports. And hub stores various ports such that when a packet arrives at one port, it is copied to the other port. Just like I told you, when the packet arrives from here, just a second, to this port, it will be copied to other, but not to this one. Let's move to the switch part. But in switch, this is not the case. Okay, let me show you a switch. Just a second. This is a switch. It has got multiple ports to connect multiple devices in a single network. Hacking in India is already pretty niche. No, no? Yes, it is. Yes. But there are some who are not just coming for the fun part. They just really want to learn and make their career in the cybersecurity field, right? So that's for whom we are going live for. For people who are coming just for time pass, this not any of our courses for them. We really want real learners for our channel and for our institute or community, you could say. Let's come back to here. So for example, one device is connected to this first port and another device is connected to the third port. So for example, the data is coming to the first port. It will not be copied to all other ports. It will be only copied to the third port and will be forwarded to the device. How that will happen, let me show you with the practical as well. So first thing I want to say, hub do not store MAC address or anything, but switch do. So switch is a network. Here you can see a network switch connects devices in a network to each other, enabling them to talk by exchanging data packets. The device stores MAC address of all devices connected to it. To store this, it maintains a MAC table where the port is mapped, vagera, vagera, vagera. Wait, let me show it to you clearly. So this is a Cisco packet tracer I'm opening now. Okay, I'll teach you how to use it. Just now, I'm just showing something to you for the demo. Okay. So here a Cisco packet tracer is up. I just want to explain some things to you. That's why I'm using it. Okay, don't worry if it looks scary to you. There is nothing. It is a very easy tool to use, Cisco packet tracer. Okay, just when you know how to use it. Okay, I have got a hub over here. Here you can see it has got multiple ports, and I can also add more ports by switching it off. Okay, for example, I switch it off, I put more ports. Okay, this is how I can put more ports in it. Okay, we will see this thing later, then I can just simply turn on and it will take some time to start working again. This is how a hub look like. So it's all like a real hub and switch and everything. Okay, it's everything is just real in this. Configurations, how it looks, how the physical structure looks, everything is real. And in switch also, you can see there are multiple ports available over here. Okay, that is used for ultimately connecting devices. Also in the configuration, you can see these are the interfaces, fast Ethernet. Okay, can someone tell me difference between ports and interfaces? Anyone knows difference between port and interface? Okay, so there are multiple interfaces over here of these ports. There are total 24 ports plus 2 gigabit Ethernet ports, which are used to ultimately connecting it to the um, router. Okay, gigabit Ethernet ports are used for connecting it to the router as well. We have got fast Ethernet port. We have got WLAN that we can set up in switch. Okay, just okay. Let's get back to what I was doing. This is my PC, and in PC also you can see this is how it physically looks. I will teach you each and everything. Okay, I'm just giving IP address to this 192.168.1.1 default gateway, nothing. Then IP over here. Ports are physical, like you can connect wires to it. And like USB port or a Ethernet port. Yes, definitely. And what are the interfaces? Oh. Okay. Okay. So here you can see I'm sending ICMP. Ports are physical and with interfaces, we logically represent them. Yes, yes, exactly, Rudra. Okay, so ports are physical, just like Hume also told me, and interfaces are the software part. You can say, okay, ports are the hardware part, whereas the interface are the software part. Ultimately, connecting the hardware and software together in the devices. Okay, so here you can see if I send from this device to from PC0 to PC3, I'm sending, and here you can see packet is successful. And also here from PC0 to PC3, I'm sending the packet. It is also successful. Which packet am I sending? I am sending ICMP packet. What is ICMP packet used for? Just a second. Let me close the gate. It's very noisy over here. Okay, I'm back. Or ports can also be like like, just a second. Like over network, like we use ports to also listen for upcoming, incoming connections. Those are different ports. I'm not talking about those ports and protocol thing. Yes, I'm talking about these ports that you just mentioned. It could be help in connecting the wires to it, right? So here you can see I'm sending ICMP. I hope this is visible to you, or I can just open the magnifier for it. Let's slide it over here. Here you can see I send the packets from PC0 to PC3, PC0 to PC3 in switch. This wala jo hai, this one is in the switch and this one is in the hub. I send the ICMP packet and it is successful. So I'm deleting the packets and let me show you something in the this part, simulation part. So in real time, it just sends how packets are sent in the real time, but in simulation, okay, here you can see real time simulation, real time simulation. In simulation, you can see how packets really travel in a network. Okay, so from here, this is a hub. You can clearly see, I hope. Okay, let me थोड़ा सा बड़ा हो जा. Okay. From PC0, I'm sending it to the PC3. Okay, I'm forwarding the packet. It goes from PC0 to hub. Here you can see what will happen. It will broadcast the packet, right? Here you can see the broadcasting. But it was meant for the PC3. PC3 received it, but all the other devices which it was not meant for dropped the packet. Now it is ICMP, so it will reply back. It replies back again to the hub and hub again broadcast it. Okay, so again, PC1 and PC2 drops it because it is not meant for them, but PC0 accepts it, and here you can see status successful, right? Status successful. So this is how packets travel within the hub. Now let's talk about this switch. Okay, this is a switch. Here you can see it's written switch. So in hub, there were interfaces fast Ethernet 0, fast Ethernet 1, fast Ethernet 2, and on this side, fast Ethernet 3. Right now, coming to here. Now I'm gonna again send packet from PC0 to PC3, and let me show you. So packet moved from here to switch, and directly it is going to the PC3. Then again, the PC3 replies to the switch, and again it's directly going to the PC1. Okay, because it stores the MAC address. How to check a MAC address? Let me show you the MAC address table. Okay, I will tell you each and everything, how to see the MAC address table, how to see everything. I will teach you how to use the Cisco packet tracer in very detailed manner. So here you can see the MAC address of the switch. Here you will see this is the what it does on the fast Ethernet 0/1. Okay, where is the fast Ethernet 0/1? Here. Okay, here you can see this cable is connected to the fast Ethernet 0/1. This cable is connected to the fast Ethernet 02. This cable is connected to the fast Ethernet 03. This one is connected to the fast Ethernet 0/4. Okay, so your 0/1 has the MAC address, this one 0010. Okay, no other MAC addresses starting with that and ending with 3184 something. So let's check the fast Ethernet 0/1 interface or PC. So this is PC, sorry, this is fast Ethernet 0/1 cable connected to fast Ethernet 0/1 port. Let's open this PC and check the MAC address of it. Okay, let's move it to the side. I'm also moving this to the side. Okay, so I'm checking here you can see MAC address. Okay, so this is the MAC address of this device, which is connected to the fast Ethernet 0/1 port, and you can see it is the same as what your MAC table has stored. Okay, so this is how your switch works by storing the MAC address of the devices. Okay, let's also check the fast Ethernet 0/2 connection. This one is fast Ethernet 0/2 connected to the PC1. Let's open the PC1 and let's check the IP address. Here you can see it's, sorry, MAC address. It is starting with 00D0, right? Here also you can see fast Ethernet 200D0. So this is how your switch works. Let's close this and your magnifier too. I hope this thing is clear that our hubs broadcast and our switch do not broadcast because it has got the MAC table. If I inspect this device, wait, my inspect is not working. Okay, let's go back to the real time. If I inspect this device and go to the MAC table, it is available. But if I inspect the hub, I am going to inspect the hub. Here you can see there is nothing like MAC table. We can only see the uplink ports and the downlink ports. Means ports which are up means which are on. Here you can see 0, 1, 2, 3 are on and others are down because they are not connected to any device and are not working. Okay. Also, you can check the ARC table in the in your switch, which is not available at the moment. Next, we have MAC table in it. We have QoS queue. We have port status. In port status, you can see which port is up and what are the MAC address of it again. These are the MAC address. These MAC address are not of the devices, but of the fast Ethernet 0/1 port of the switch, not of the PCs. Okay. In MAC table, we see the MAC address of the PCs, but in this port status summary, we see the MAC address of this switch, not of the PCs. Now, if you guys have any question, I am checking the comments. Let me know. So, like you can connect wires to it, like a USB port, Ethernet ports are physical and interfaces where logically. Or ports can also like network. Okay, network testing. What is this network testing? What do you mean, Rudra? What do you mean by network testing? Guys, if you have got any questions, do let me know. And also, you can contact me on the number given in the description below for asking your doubts or for reviewing your resume or for if you need mentorship. You can also contact on the same number. We can take classes in both Hindi, English as per your requirements. Okay, so this was how our switch was. So let's talk about switch and about router. We will talk tomorrow. Okay, this is the last topic we are covering. So working of switch, when switch receives data from one connected device, it forwards data only to the port on which the destination address is connected. Means it will only copy the packet to the port on which the destination system is connected. It uses media access control address of the device to determine the correct port. Okay, it has got the MAC address stored in it, MAC table. In MAC table, the port number and the MAC address is stored in it, which helps in identifying which port to send data to. Then it refers to MAC table, which stores MAC address with corresponding port number. As it works on the principle of second layer of OSI model. It works on the second layer of OSI model, that is your data link layer of OSI model. And as I told you, we will discuss this OSI model all in detail after a few lectures. Ma'am, this looks kind of complicated. Oh, no need to worry. Just remember that your hub broadcasts the packets and copies it to all other ports, but switch do not broadcast the packet, and it forwards the packet only to the destination port. And What else? And it stores the MAC address. That's it. These 3-4 points are you have to resemble. Tell. What if it fails to find the destination system? Okay, what if it fails to find the destination system? Let's see. Okay, so I'm opening this device, I'm opening this PC, and I'm going to the desktop command prompt. I'm going to the command prompt and I'm pinging. I ping. I ping what 192.168.2.4, which is available, right? I'm pinging to that system. So what? Sorry, 2.4, not 2.4. Okay, here you can see 2.4 do not exist. 1.4 I had to put, but by mistake I put the 2.4. It will just simply say request timed out, host not host not reachable, request timed out or host not reachable. That is what it will say, right? That's it. It will return an error. As simple as that. Okay, now pinging the correct IP 192.168.1.4, which is available in the network. I have configured it myself. You can see reply from. I will get the reply from it. And otherwise, what will happen? Request timed out or host unreachable. Okay, I will receive these two errors. Request timed out or host unreachable. Let's try some other IP that do not exist once again. Command prompt and ping google.com. Here you can see ping request could not find the host google.com. Please check the name and try again. Right? Because in this network, there is nothing like google.com. In this network, this is a complete different network in a sheet. So it has got not no google.com. So it will reply back with the error. So that is through ICMP. Yes, it could be through ICMP or any other protocol. First of all, it only checks now the reachability of host. Whether TCP protocol is being used. No need to worry him. There is nothing complex in it. When we will start with the practical, I'll again show you this hub and switch stuff. Okay, I will explain again each and everything practically in the detail. Everything practically. So yes, this is pinging. I like this also. I was using the ping packets only, and in that way also, in like using the command prompt also, I was using ping. That is by ICMP protocol, Internet Control Message Protocol. Yes. Okay. And guys, please do like the video. Let's continue. Now we have got cascading. So when two switches communicate with each other, if you want to connect switch to switch together, we call this process cascading, and we do it using the crossover cable. So we will talk about the cables in the upcoming lectures. So we will talk about what is crossover cable, and if we do not want to use crossover cable but straight through cable, we can simply use the crossover port MDIX and out port. These are some ports available on the switches in the modern switches. So we can use these to connect the switch to switch using the straight through cable as well, if these ports are available. Otherwise, crossover cable has to be used to connect same type of devices. We will get to this later. Okay, that's it for the switch. And next device we have router, which we will continue tomorrow. Okay, we have routers, we have bridges, we have repeaters, we have gateways to discuss, we have multiple things. Then we will get to the cable part and ultimately to the your OSM model part. So thank you everyone for watching today's lecture. And I'm really grateful to have students like you. Thank you for subscribing and do not forget to like the video and subscribe to the channel. See you tomorrow at 10. Bye bye. Thank you for watching. If you got any doubts, you can tell me in the comments in the chat, or you can also tell me in the